Okay, so we're going to do another transformation in vertex form, just for an example. So we'll put a little 2 there for part 2. This is our second one. So we have a second equation here I've written. So y equals negative 1 over 4 bracket x minus 3 squared plus 2. So we can write our vertex. We can just read this right off the chart. So it's 3 comma 2. And our a value equals negative 1 quarter. So we know it's going to open downwards. So let's draw our graph here. So let's find our vertex. So we go 1, 2, 3. Then we go up to 1, 2. So it is right here. That's our vertex. And it opens downwards. So we'll write this here, 3 comma 2. And now let's do a little table. And we'll do our table going this way. So if x is 2, or if x is 3, we know y is 2. We have that just right off our vertex. What happens if x is 2? So we put 2 in here. We have a negative 1. Negative 1 squared is 1 times a negative quarter. So that's just negative quarter plus 2. So that's 2 minus a quarter, or 7 over 4. That's a wonky looking 7, but 7 over 4. Okay, now what happens when x is 1? X is 1, that's negative 2. Negative 2 squared is 4 over 1 quarter. That means it's negative 1, so we have 1. Negative 1 plus 2 is 1. Okay, and we'll do 0 and 0, and that is negative 3. Negative 3 squared is 9. 9 over negative 1 quarter times 1 quarter is now, oh god, plus 2, it's negative 1 quarter. You can check the arithmetic, but that is what it is. Okay, so now let's plot these points. So we go to 2, and we're almost at 2. It's actually very close to 2. Just only move down a bit. When it's 1, it's at 1. And then we're here, we're just slightly negative. Like here's negative 1. So we can see the parabola is just really wide. It's going like this, very slow. And this is our axis of symmetry, right? I think I'm drawing it relatively straight. So we know that if we went over 1, it'd be here. If we went over 2, it'd be here. If we went over 3, it'd be here. So we can kind of, oh, I shouldn't turn it so much, but it makes for an easier line. So this is essentially what we've done for our graph. We graphed everything properly, and I've chosen a really bad spot to write the equation for it. So let's just scribble that out. And you know, I won't write it there. That's the equation of the graph. We know that anyways. So what else can we find here? We know that x equals 3 is the axis of symmetry. We know our y-intercept. Our y-intercept is y equals negative 1 quarter. We can see that we have 2 x-intercepts. We have one here, and we have one here. I think that's it. Yeah. So then we write our domain. The domain is a set of x such that x is an element of a real number. And that's it for all polynomials. And then we do our range. And our range is y such that y is an element of a real number and y. So here we see that it can't be bigger than this. Y has a maximum. So y has to be less than, but it can equal 2. And that's it. So if that's, oh, we can also say that a equals -1/4, which we wrote up here, but that means it opens down. And it's squished. So we kind of squish the whole graph that way. Cool.